Hello, everyone. This part is specifically for those of you who may not have a very strong chemistry background or feel like you need to review some of the science content a little bit more. Okay, so these are mostly those slides from this chapter PowerPoint. Okay, so let's start at the beginning. Atoms and molecules. Atoms are the smallest particles. They basically are contain those protons, those neutrons, those electrons, and those atoms. If they're all of the same type, then those become elements. That is basically the simplest pure substance that we have in our existence. And here you can see a picture of an atom. These are some major terms that are very important in basic chemistry. Periodic table, you won't need it for the class, don't stress. Molecule is something that is bonded to more than one atom, and they typically are covalent bonds. Compounds are molecules containing more than one element, so that would be like salt, sodium, and chlorine bonded together to make sodium chloride. Atomic number is how the periodic table is arranged, and it shows you the number of protons that is in that atom. The mass number is the protons and the neutrons together. We do not include the electrons because they are too minute. Isotopes. Now, these are important. These are atoms of the exact same element. However, they have different masses. They may weigh more, they may weigh less, and that's based on the fact that they may have more or fewer neutrons in their nucleus. Now, this we will spend a little bit of time on. This is radioactivity. And radioactive decay is important in environmental science, not only because can it be extremely dangerous if it gets out, think Chernobyl, but also we can use radioactive decay as a means to date things in archaeology. So it's a very useful tool that we can use as well as it be dangerous. So, but basically, it is the spontaneous release of energy and material from the nucleus of different isotopes that are radioactive, like uranium, plutonium, things like that. The definition of a half-life is it's the time it takes for one half of the original parent atom to decay. So, for instance, there are some man-made elements who are highly radioactive, but they only exist in the lab because their half-life it may be 2 or 3 seconds, or even shorter, before it degrades into the next sized atom down. And covalent bonds are a bond that occur when you share electrons. They only occur whenever you deal with non-metals. There are no metals in a covalent bond. So that kind of brings us to the three types of bonds. I don't know why it made that transition. Covalent, as I said, are non-metal, non-metal, all non-metals. Ionic bonds, they transfer electrons, metal and non-metal. And then hydrogen bonds are exactly what they sound like. They're hydrogen. They have hydrogen in them. So this slide here shows how those electrons are formed. I'm not going to spend any time here other than tell you you can pause it and look over this if you want. Ionic bonds literally give or donate an electron. The metal usually does this and donates one or more electrons to the non-metal, forming ions. Hydrogen bonds they're not very strong, but they're particularly helpful in that they really kind of help create a lot of polar molecules, meaning one side's more positive or negative than the other. And this really changes the behavior of a substance like water. So water is a highly polar molecule. Polar, like I said, just means that there's different charges. If you look here, it looks like an upside down Mickey Mouse. And basically that top, which you normally see as the bottom, the end of the oxygen has a lot more electrons, so it's negative, and the hydrogens are more positive. So if you take a look down here, you'll see that this positive end of this water is attracted to the negative because opposites attract. And that's how those hydrogen bonds form, is that attraction. Water is, it's the universal indicator, solvent. I mean, it's all sorts of, it has, it's a very bizarre molecule if you think about it, but it's also one of the absolute most useful one in our existence. So not only is water polar, but it also has some other cool properties. It demonstrates surface tension really well. So if you think about whenever you see like a little bug on top of the water and he's not falling through, that's due to surface tension. Capillary action is another one where the water adheres to the surface of other things like glass, like a little, think of like a little tiny glass tube. Let's see here, it gives you some temperature references, which you should know. And this right here, many substances dissolve well in water, and that's why we call it the universal solvent. A little bit more in chem. Acids, bases, and pH. We will also talk about these. Acids are things that contribute hydrogen ions to a solution. They are substances that have corrosive properties. The stronger their acidity is, so the lower on the pH scale that they are. Bases are the opposite. They are higher up on the pH scale, but they can be equally corrosive. Just, you don't really think of it. I mean, you don't think of a base doing that, but they can. And instead of contributing hydrogen ions, bases contribute hydroxide ions, which is OH, and it's a negative ion. So the pH scale is this really important scale that we will use that goes from 0 up to 14. The middle, which is exactly 7, obviously, is what we consider to be neutral. Anything lower than 7 is acidic. And the closer you get down here to 1 and 0, the more acidic you are. Bases go up to 14. And the higher you get to that end of the scale, the more basic or the stronger the base is. All right, so why we're talking about all this is because all of this is important to the environmental systems that we are going to be analyzing through the year, okay? We will look at different chemical reactions to help kind of figure out how and project maybe what an outcome might be of that. So if too much, like how does acid rain form? What are the consequences of that? That kind of stuff. The law of conservation of matter is very important. Law of conservation of matter is very similar to the law of conservation of mass. Basically, what we have is there. You cannot make more. You cannot get rid of it. It's not just going to dissipate into outer space. It will be converted and it may change form, but matter and mass cannot be created nor destroyed. All right. Inorganic compounds are ones that that typically do not contain carbon. They usually have, it could be another type of covalent bond, usually ionic bonds that are really obviously identifiable as inorganic, like this, that sodium on there is a metal, bam, that's an inorganic compound. Organic compounds are ones that are carbon-carbon atoms or carbon-hydrogen atoms. So hydrocarbons, you've heard that term. So those are going to be your organic compounds. different than organic farming. All right, these are the major biological molecules that you learned in biology, and these are the ones that they can be very adversely affected by different types of pollution and chemicals and stuff like that. But you do need to be able to recognize what these are. This is the definition of a cell. You know this. There's some single cell organisms out there. Again, you know this. Bacteria. The ones that you normally think of are multicellular because they're obviously bigger and they strike a little bit better impression in your brain. Okay. Now, let's talk a little bit more about physical sciences. Energy is extremely important. Energy, the definition, you need to know that. It's the ability to do work or transfer heat. That's why you sweat when you work out, okay? You're transferring heat because the energy is being converted into that heat. Joule is a unit that measures energy. Power is the rate at which work is done. So how much work are you able to do and within a certain amount of time? Now, energy conversions are something that we will be working with. So you need to kind of have your head wrapped around some of these, just kind of be cognizant of what a calorie is, what a kilowatt hour is, because we will be doing some conversions. Again, those factors will be given. The major forms of energy, electromagnetic radiation. So that is any part on that spectrum. It could be anything from UV to gamma rays, microwaves, radio waves, all of that. Photons are tiny little packets of energy, and that's they move at the speed of light because it is light. Potential energy is stored. Kinetic energy is in motion. Chemical energy is stored in bonds. The food you eat is chemical energy. And temperature. So temperature is a way that we can help monitor energy change. And you'll talk a lot more about that in chemistry and physics. All right, so that's a crash course of basic science from chapter 2. If you have more questions related to some of this, let me know, and I'm sure I could provide you with some more resources.